We'll be talking about digitalization for electrical engineering. So let's welcome our expert in the field. Here is Gerhard Fliel. Welcome.
Thank you.
Nice to have you.
Hello. Good afternoon, ladies and gentlemen. So in the next session, digital toolchain for electrical engineering, I'd like to show you how you can tap the potential of digitalization in the field of electrical engineering. But let me start with some generic remarks. Everybody knows digitalization is on the rise. Digitalization changes everything, big words, commonly used. What does it actually mean for electrical engineering? That's the focus. Because companies, they have to adapt, they have to follow the digitalization in order to stay competitive, but at the same time, it provides also big opportunities. It accelerates business processes and also engineering processes. I mean, think about the increased demand for flexibility, for customized mass production. For instance, when we talk about panel building, each and every panel, especially in the discrete manufacturing industry, looks differently. How can I follow this demand for customized mass production and at the same time increase my efficiency, my flexibility, only through a holistic approach? So the focus has to be on the entire value chain, not only on a single step like production engineering or production execution or service. No, a holistic approach is needed and necessary in order to tap the full potential of digitalization. Well, to give you also an example on the products and on the product relevant data and information which is needed for a project today is tremendously increasing. Yesterday it might be sufficient to have some parts list and diagrams, partially digital data. Today we provide already a ton of macros, 3D models, and tomorrow we talk about the digital twin. That means, what does it actually mean, a digital twin of a product? The full comprehensive description of a product in a digital format. So one-to-one, the counterpart of the real actual product. Well, Siemens has already an answer about when it comes to the entire value chain and how to support this, the digital enterprise suite from Siemens. But we are also aware of that not everybody, in terms of investing the money and know-how, can use the full-blown digital enterprise suite from Siemens. I'd like to show you also how you can benefit of the digitalization in electrical engineering without having the full software portfolio. All right, when we talk about product data, I think we need to take into account also that these data need to be permanently secure, of course, systematically sorted. Just think about the sheer amount of data. I mean, how can they be located? And especially if several engineers are working on the same project, so simultaneously accessible and, last but not least, always available 24/7, no matter where this engineer sits or the engineering team might be spread out all over the world. So that's also an important part of digitalization and when we talk about the electrical engineering and how the digitalization affects it. Okay, so once again, a holistic approach is necessary and it results in great opportunities for control panel engineering. Increased efficiency, this is needed. I mean, I talked about the customized mass production. How can I be more flexible? How can I increase my quality at the same time? And especially when we talk about control panel engineering, control panel building, it's a very competitive business. How can I shorten my time to market? How can I increase my speed? That means how can I shorten my engineering workflows? So the focus is on a seamless interaction of all engineering steps, whether we talk about the mechanical engineering, the electrical engineering, and the automation, seamless interaction, exchange of information to bring this together. This is important and the focus should be on that one. Okay, and I can tell you, Siemens is on your side on the way to digitalization. It has already started, but it's a long way to go. And we want to make sure at your side to assist you that your product becomes, at the end of the day, a better product, a more efficient one with a better quality. Okay, let's be a little bit more precise and let's look into the engineering steps. I mean, this we've seen in most of the engineering steps, they are executed, they are performed sequentially. In many cases, it starts with the mechanical design of a machine, for instance. Then afterwards, the automation, the programming, the parameter assignment, and at the end, the electrical design for the cabinet layout, the schematics, the wiring diagrams. So, but the engineering steps are in many times executed, performed sequentially, one after another. If there are change requirements, well, it affects the engineering step before. How can I make sure that I don't have faulty data? How can I make sure that the exchange of information does not provide any or does not cause any errors or faulty data? Well, this is our vision. This is what we want to do. We want to have engineering tools which provide common interfaces in order to form an integrated workflow between all this engineering process, and especially with a focus on the electrical design. So I just put the three main disciplines, mechanical engineering, electrical engineering, and automation, in a different order, not sequentially. Now the exchange of information, that's our vision. We want to exchange it between all the three main engineering processes, whether it's the automation with the parameter assignment, the programming, or the electrical design where you select the switchgear components, controls, breakers, drives, the actual control cabinet design, the layout, the circuit diagrams, or the mechanical engineering where the mechanical engineer defines the sensors, the actors, the motors, the machine design, the load curves, and so on. So an exchange of information is needed here. And the integrated toolchain allows this, the permanent and persistent exchange of information in between those engineering disciplines. Let's have also a closer look what Siemens provides already today regarding the digital toolchain, which different tools, for instance, configurators for sizing and selecting the proper products for the individual engineering processes. Whether it's for the mechanical design, you may use an external software, a CAD, CAE software, or maybe a Siemens software tool. The sizer for selecting the proper drive or drive configurators. For the automation, the tier selection tool and the tier portal and the PLC simulation. Or for the electrical design, there are also different tools, engineering tools and configurators, like the tier selection tool. Again, it's not only for automation components, but also for non-communication capable components, product configurators, Simaris design for network calculation, load curves and short circuits, Simaritherm for the heat calculation, and so on. So many tools are connected, exchanging information in the digital tool chain. Okay, and now I'd like to show you a practical example. One of these tool chains is already available. I just replaced now the generic terms with three tools. You probably know EPLAN, a very common used software tool for the electrical engineering on the market, especially in the discrete industries. The tier portal for the programming, for the parameter assignment, and the tier selection tool for sizing and selecting the proper products. So the exchange of information in between those three tools is already possible in order to increase the efficiency, be more productive, and at the same time avoid faulty data, especially when it comes to change requirements, change requests for the design. So information can exchange between the tier portal and the tier selection tool, between the tier selection tool and EPLAN, and also, of course, tier portal and EPLAN. And this comes with a lot of benefits. So the product selection in one tool, the tier selection tool provides you configurators to size, to select the components for automation, for drives, for controls, for breakers. Submit the entire PLC configuration directly to tier portal, and also the complete hardware configuration to EPLAN, including all the low voltage components. Exchange easily the addresses and the PLC configuration between electrical and automation engineering. And last but not least, experience an integrated electrical engineering, a holistic approach when it comes to this engineering for increased efficiency. Okay, so a digital tool, a digital twin, of course, that's a prerequisite, is available for each engineering stack. And I can only emphasize this, how important is this, and Siemens is on a very good way when it comes to these data which are needed here. For instance, in order to guarantee the digital twin of the entire panel, well, I need for my single components I use and I install in the panel a digital twin. And once again, we distinguish usually between the three main disciplines: mechanical engineering, automation, and electrical engineering. Product master data, commercial data are needed to be available. Function blocks, simulation relevant data in order to simulate the digital twin to avoid a prototype. Power loss data, circuit diagrams, This is the digital twin. This is a prerequisite of, in order to design the entire panel as a digital twin, I need the single components in a digital format. Okay, and this is also a claim, this is our message. With a digital tool chain between the engineering disciplines, they require time, and at the end of the day, of course, the costs can be significantly reduced. To give you a case example, well, once again, here on the left-hand side, you see in most of the cases, still the engineering occurs sequentially, one engineering step after another. Tomorrow, with the digital tool chain, first of all, the required time, the workflow, the time for the workflow will be shortened, or can be already shortened with that practical example I just showed you. Saving time means saving money too. And on the right-hand side here, we see the three main cost drivers when it comes to control panel engineering. Of course, we need certain material for our components. We have assembly time and wiring time, and of course, and there is the biggest potential, the engineering time, the design, the documentation. And the biggest potential for saving time lies definitely in this, for this cost driver in the middle when it comes to the engineering. And with the digital tool chain, with the exchange of information between the three main disciplines, for instance, with those interfaces I've just shown you between EPLAN, tier portal, and tier selection tool, more efficiency, more productivity, and that means at the end of the day, saving time and saving money. So once again, Siemens wants to be your partner on the way to digitalization, that your product becomes a better product for increased efficiency, better flexibility, higher quality, and also, of course, at the end of the day, time to market. Save time, increase the speed for your engineering workflows. If you want to see this in practice, how it works already in practice, right behind the forum here on my right-hand side, there are several workstations, and we are more than happy to take your questions and to show you in practice how this works already, the interfaces in between those engineering steps. Thanks for your attention. Enjoy your time at the Hannover Fair and have a good day.
Give a big round of applause, ladies and gentlemen.